Hey geometry students, welcome to week 4 where we're going to continue learning about congruent triangles like last week. And at the end of last week on Friday, we did a Desmos activity where we tried to figure out like faster ways to know that triangles are congruent. So that's going to be the focus of our lesson. We're going to kind of go over some of the things that you guys noticed and thought about on Friday. Quick reminder, today is Monday, right? Our asynchronous day. There's no class Wednesday due to Veterans Day. So I will see you next in Zoom on Friday. So here we have two triangles. We have triangles A, B, C, and I'm going to kind of color code A, B, and C. And remember, it is helpful if you're trying to figure out what the congruent or matching triangle is to color code. So the yellow has the angle with the 1 tick mark. That matches, right? The blue has with 3 tick marks. 3 tick marks. That will match with E. And C has 2 tick marks. That will match with D. And I'm going to fill in my letters. So it's going to go yellow, blue, purple. Excuse me. So our congruent statement is triangle ABC is congruent to triangle FED. Notice the order is important because the order is implying specific angles and they each have distinct measures. So that's why we have to be careful about the order. I could have named triangle ABC in a different order, right? I could have started with blue or purple. That would just mean I would have to start the other one in a different order and be consistent. So triangle congruent shortcuts. So you don't actually need to know, like if we look at the picture below, that all 3 pairs of sides are equal and all 3 pairs of angles are equal, right? That's what it's referring to with all 6 corresponding parts, right? Your 3 side pairs and 3 angle pairs. So we actually don't need to know all of those facts. And so there are some shortcuts that only need 3 different things. And the shortcuts that we're going to see are going to come from the activity that you guys saw in Desmos. The first one is called side, side, side. And what that means is 1 pair, 2 pair, 3 pairs. So that means that all corresponding or matching sides are congruent. All corresponding. Should be 2 R's. It looks a little weird. Sides are congruent. I'm just going to put the congruent symbol. Remember, the good thing to remember about for that one was when I, in Zoom, used my 3 pencils or pens. And if you think about pencils or sticks, right, if you have 3 distinct pencils, there's only one way to make a triangle. The other one that we saw was called the sandwich. And it's that you have a matching side. You have a specific angle in between. Excuse me. And you have another pair of matching sides. So what this means is that all of this is stuck. Remember, all of that is stuck. So we picture it kind of like you had one thing that's stuck, right? Another thing that's stuck, an angle. There's only one side that you can connect to make the third side of the triangle, right? Excuse me, I swallowed some water funny, right? So think about it like if you have 2 pencils that are connected in a specific way and you're not allowed to change the angle between them, they're stuck. You can only connect along that one line, and that's what this is trying to show here. The other one, and I remember that Jonah asked a good question about how these compare. Remember, these are sandwiches, right? So in this case, the bread is going to be the angles. So the angles are going to be on the outside. And then in between them is a specific side. So I'll mark the specific side. So notice how these 2 sandwiches are different. Maybe make a note that these I call the sandwiches. And then this one was a little different. This one, remember we talked about together, if you have a specific angle, followed by a specific side length, followed by another specific angle, maybe it's a little bit bigger, right? If you have to have those requirements, right, if you kind of envision that that angle is stuck, so making the blue side, I could make it really long, really short, right? Pink side, I could make it longer or shorter. Eventually, there's going to be a point where those cross, and that's the only place to have a triangle that satisfies that those angles are stuck That side is stuck, right? These are not changing. Think about if you tried putting the point over here, this side would be tweaked a little, this side would be tweaked a little. Notice that the angle, the pinkish red angle is bigger, the blue one is smaller. That would not work if we can't change the angles. So you're really constrained based on that one. The other one that we explored was angle, angle, angle. And remember, that one did not work. That one, remember, we had a good example. Someone drew like a little right triangle and a big right triangle where you have all the angles matching, right? But one of them has been stretched. Think about it like stretching a computer image. So the three at the top are the only ones that work. There's also one that I think is really connected to the angle, side angle. Some textbooks you will see something that looks like this. Let me just pause. So some textbooks use this one and they call it angle, 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 side. I don't really like teaching this one as a separate one, and here's why. If I know specific angle measures, like let's say that this is like maybe 40 degrees, right? This is also 40 degrees. If I know that this is 60 degrees and this is 60 degrees, right? We logically could use the triangle sum of 180 degrees to figure out 40 and 60 is 100, right? That this is 80 degrees and this is 80 degrees. So in essence, what this kind of turns into, I'll move this over here so I can mark the angle. What this really just turns into is, because of that, this angle and this angle are also equal. And then you get your angle, side, angle sandwich. So I don't see angle, angle, side as a separate case. I just kind of see it as taking one step to get to angle, side, angle sandwich. So this one is kind of like a weird case. I would say that these are the three you need to know, right? Know that the angle one doesn't work. And this is kind of just an aside, angle, angle, side. One thing to note, a lot of students always wonder side, side, angle, right? Having a side, and then an angle. Notice if you go backwards, it spells a word that you're not allowed to say in school. And that's always how we remember that this one does not work. To see why, I'm going to pull up a good internet picture and you can add this to your notes. Okay guys, so what I've done is I've Googled side, side, angle, triangle doesn't work. And I think that this visual I have over here on the side is a really great example. Notice you've got a side, the green one that's congruent to the other green one, followed by the orange side, and then you have an angle next. Because that angle is fixed, right? We can't change the angle, and we can't change the orange or the green side. Do notice, however, that the angle between the orange and the green side is able to be changed. So notice that if we change it, it looks like there's actually two possibilities, right? You have where you've got a little acute angle, or it looks like you can make it a bigger angle. And you have two distinct triangles where you're keeping everything else the same. So because we can think of an example where if you have if you have side, side, angle, a side that's congruent and a side that's congruent and an angle, because it's not always the same triangle, this does not serve as a shortcut to show that triangles are congruent, right? There can't be any cases where it doesn't work. So that's why that one doesn't work. We talked about the angle one earlier. So the three at the top, right, are pretty easy to remember. Your sandwich, your other sandwich, and your all sides. And we kind of just did this, so I don't think I need to really make a secondary video explanation. We kind of rehash what we talked about in Desmos. Now, I've got a couple of examples just to practice your shortcuts, make sure you're feeling good. So we're just going to practice naming the shortcut for why the triangles are congruent. So I'm going to have you pause your video, unpause when you're ready. If you said side, 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 you're correct, right? Knowing the three pairs of corresponding sides are equal is a shortcut to assume the two triangles are congruent. If I had letters, I'm just going alphabetically, you could say that triangle ABC is congruent to triangle DEF. Notice that A is between the 1 and the 2 tick mark. D is also between the 1 and the 2 tick mark. B between the 3 and the 2. E between the 3 and the 2. That's how I'm double checking. And we would say that they're congruent by side, side, side. That's kind of like your support for why they're congruent to each other. Let's try another one. So take a second, think about why they're congruent, and unpause when you're ready. You're right, you got the side angle side sandwich. Notice the angle is in between sides of the bread. Make sure as we're doing these, you guys are drawing them in your notebook. Here's another example. Pause it, unpause when you're ready. We've got an angle side angle sandwich. Make sure you've drawn this example in your book. Another one. Now this one, remember this is a weird one, so take a second and try and think about it. It might take you a moment. Pause the video and make sure you draw it out. Unpause when you're ready. Because these two pairs of angles are equal, we can assume that the third would be congruent. That's using the sum of angles is 180 degrees using that theorem, right? If you've got two angles, the third has to be whatever else adds to 180. Using that, we have a sandwich. So this is your angle, side angle, right? This is that kind of adjacent one that we saw up at the top. If I kind of scroll back, this is that bottom middle one. It's kind of like a small additional step compared to the top right. Okay, and I think we got maybe one more. Yep, I think this one might be our very last. Oop, we got two more. So for this one, you might need to unpause it for a hint, but try pausing it, drawing it, and thinking. Here's the hint. We've got crisscross. Remember, those are vertical angles. Remember, vertical angles are congruent. Marking in your vertical angles, we can then do a side angle side sandwich. So you'll see in this section that vertical angles are going to be coming up. So remembering that vertical angles are across from each other in the intersection and they are equal. One more example, make sure you've paused the video and written out and drawn your diagrams, right? Make sure you're pausing and drawing as we go. Here's the last one, make sure you pause it, draw it. Think about on your own what the answer might be before you unpause. So in this picture, they're actually sharing a side, right? Notice that both triangles have B to D. So that means if I was to draw them separately, right, you would kind of have this look, right? Notice because you have B and D, right, that's the same side, that's the same length, right? So typically on a picture, I will mark it like this. This is called a reflexive property. And it's just the idea that BD is congruent to BD, right? That segment is equal, so you know that it's the same in both triangles. So because that's true, we have a side, side, side example. Make sure you've drawn it out. We would say that triangle ABD is congruent to triangle. Now notice I go A to B, right? So we would go C to B. C, B, and then D at the end. Okay, that's it for today. I will see you next on Friday, and we're going to do some practice with this and end class on Friday with a short mini quiz. It will probably just be some multiple choice just to make sure you guys feel good on the properties. I'll see you guys then.